So we're in Unit 7, the mole, and we're talking about molar mass. Molar mass was something that for an element we found on the periodic table, it was the atomic mass number. It is the number of grams in 1 mole of an element. Then in the previous video, we used those numbers and our chemical formula to figure out the mass of a compound. And so now that we've done that, we can go a step further, and this is where it really becomes helpful. We can create conversion factors from the molar mass. This is where we can take our mass in grams that we got from a balance, and we can change that into moles so that we can relate it with other chemicals in a chemical reaction. It's kind of our way to measure everything. So when we're going to make a conversion from mass to moles, here's what it looks like. Mass to moles, we're talking about putting moles on top because that's what we want, and grams will be on bottom. And so what we have here is the molar mass, and it ends up being, remember, molar mass had units of grams per mole. This is just flipped upside down, and now we have moles per however many grams. For moles to mass, it would be like this. 1 mole has a certain number of grams, and that number is the molar mass. So let's look at an example here. So let's say that we have 10.0 grams of silicon dioxide. And we need this silicon dioxide to be measured in terms of moles. And so this becomes a conversion. So here's a dimensional analysis portion of a question. We put this over 1, and we need the molar mass in grams to be on bottom, and we're looking for moles that will go on top. Now the 1 mole part is always the same, but the number that goes right here is the mass of the compound, the molar mass of the compound, and we have to figure that one out. This is what we did in the last video. So if you're still using the table, that's fine. We're going to draw the table here. If you are beyond the point where you need the table, I would still recommend writing it down in the examples, and then when it becomes your turn, you can skip to the shorter method. So we need to know the molar mass of silicon dioxide. This is the table that I was making. The first column lists the elements involved in the compound. The second column was the molar mass from the periodic table directly. For silicon, it says 28.0855. I'm going to round that to 3 significant figures. And oxygen, 15.9994, becomes 16. The next thing is the quantity, and this is the number from the chemical formula. So the chemical formula here tells us that we have 1 silicone and 2 oxygens. and then we can make the total. So remember what we're doing here. We are multiplying the molar mass times how many of each atom. So 28.1 times 1 is 28.1. 16.0 times 2 is 32.0. And the total mass is everything in this column added together. So 28.1 plus 32.0 and we find that it is 60.1, and that's grams per mole. So now we're going to take this number and put it in right here. $60.1, and that's grams per mole. Then we go to our calculator, we type in 10.0 divided by 60.1, and we find is 0.166 moles. And we want to get in the habit of labeling the chemical that we're talking about. It'll be a good habit starting in the next unit. Let's just get it going now. 0.166 moles of silicon dioxide. We figured out this amount of the substance based on a mass measurement that we took in our lab. So let's try another one. Let's say that we have 10.5 grams, and this is PbNO3 2. We're talking about lead to nitrate. And we want to know, based on this mass, how many moles do we have? In order to do this, we have to know the molar mass of lead 2 nitrate. And so let's set up our table. All right, so first up, we're going to list the elements that are involved, and that would be Pb, lead, N, nitrogen, and O, oxygen. To the periodic table for our molar masses, we find that lead is 207.2, which we'll just round to 207. Nitrogen 14.00, 14.0. Oxygen 16.0. Then our quantities come from the formula. So looking at the formula, it tells me that I have 1 lead. Now this one is a little bit tricky because we have to pay close attention. So here we have a nitrate which just has 1 nitrogen, but there are 2 nitrates, which means that really I have 2 nitrogen. And then oxygen, I have 3 oxygens in a nitrate, and I have 2 nitrates. So these 2 numbers will multiply. That tells me I have 6 oxygens. Total them up. There's 207, 28.0. 16 times 6 is 96.0. And we're going to add this column together. Remember our significant figures rules. The number with the least digits after the decimal determines the significant figures when we're talking about addition. So these point zeros are just going to disappear. So we start adding these up, 15, 21, and we've got 3. So we find that our molar mass is 331 grams per mole. So we bring that number up here, 331 grams per mole. So putting it in the calculator, we see it is 0.0317 moles PbNO32. Or you could write this in scientific notation if you wanted to. 3.17 times 10 to the minus 2 moles of PbNO32. So here we have the number of moles in 10.5 grams of this substance that we measured on our balance. So let's work the other way. Let's say that we know a number of moles, but now we want to know what should the mass be. And so let me draw a line here. Let's say that we have 3.38 moles of a substance, and the substance is magnesium sulfate, MgSO4. And I want to know how many grams of magnesium sulfate should I have. And so I want to know, if I put this on the balance, how many grams do I need to have to make this amount. So we know that in 1 mole of magnesium, there's a certain number of grams. And we need to find the molar mass to put into this conversion, into this calculation. So setting up my table, MgSO4, molar mass, quantity, total. First column, we have magnesium, we have sodium, we have sulfur, and we have oxygen. Molar mass of magnesium rounds to 24.3, sulfur 32.1, oxygen 16.0. For quantities, we have 1 magnesium, 1 sulfur, and 4 oxygens. So that is 64.0. We add the totals column. So 0.4, 120.4 grams per mole. And we used to 3 significant figures, and so we're going to call this 120 grams per mole. So we come back up here, 120 grams in 1 mole, and we have 3.38 moles of magnesium sulfate. So we are multiplying these two numbers in our calculator, and we come up with 406 grams of MgSO4. So another one, let's say we have 0.408 grams of PCl3. And we want to know what is the amount of PCl3 I'm talking about moles here, excuse me. I'll back up and erase that. 0.408 moles of PCl3, and we want to know what is the mass in grams of the sample. If we had a sample that we know is 0.408 moles, we should be able to put it on a balance and expect this amount. And so what is that amount? And so this is what we're looking for. So we're making our table. We have phosphorus, we have chlorine. Phosphorus rounds to 31.0, chlorine 35.5. 1 phosphorus, 3 chlorines, and then add them together. (137.5 grams per mole), and let's go ahead and round it to 3 significant figures. 138 grams per mole, and that number will go here, 138. So we are multiplying our number of moles by our molar mass, and we find that it is 56.3, and that is grams of PCl3.